So this is question 66 from our JAMB Physics Marathon Revision class. So question 66 says that a cell gives a current of 0.15 ampere through a resistance of 8 ohms. So we have current. So the current that is given in the first place is 0.15 ampere. Then the resistance that it gave this through was a resistance of 8 ohms. So let's call this R1. And it also gave a current of 0.3 ampere through a resistance of 3 ohms. So the question asks us, what is the internal resistance of the cell? So from what we know that internal resistance, EMF equals I multiplied by R plus R, where the small r is the internal resistance. So we know the current and the R in each case, so we just have to substitute there. So in the first case, we will have E equals 0.15, then 8 plus small r, and in the second place we have E equals 0.3, then we have 3 plus r. So from this particular thing now, from equation 1, so we can say from equation 1, we know that E is the same thing as 0.58 plus R. And since these E are the same thing, so we can equate them together. So we don't even need to say from equation 1. We could just equate the E, since it is the same E we are dealing with. So this will now be that, this implies that 0.15 8 plus R equals 0.3 3 plus R. So when we do this calculation, so what we are doing now is to solve for R. So we have 0.3 divided by 0.15. So with this now, we have this will be 2 like this. So that implies that 8 plus R, then we can use the 2 to open the bracket here. So that will be 6 plus 2R, 6 plus 2R, and that definitely implies that 8 minus 6 equals 2R minus R. So if we do this very well, that means 2R equals R. So that implies that the internal resistance of this cell is 2 ohms. And that's question 66. So for question 67, we have that 20 electrons flow through a conductor in 16 nanoseconds. So we have number of electrons. Number of electron is 20 electrons, and the time that they are flowing is 16 nanoseconds. So we have to determine the current flowing in the circuit if the charge on an electron. So we have to determine the charge on the electron. So determine the current flowing. So we have to determine the current flowing. So current is what we are looking for. So from what we know that Q equals IT, where Q is the quantity of electricity that is flowing. So in this place, the quantity of the charge. Now from here now we have 20 electrons. So that implies that we have 20 multiplied by, so we know that on one electron the charge on it is 1.6 times 10 raised to the power minus 19, and then we are looking for current. So this thing flows for 16 nanoseconds. Nano is of the magnitude of 10 raised to the power negative 9. So then with this now we can solve for I. So this implies that I equals 20 times 1.6 times 10 to the negative 19 divided by 16 times 10 to the negative 9. So from this now we have If we reduce this properly, we will have 2 times 10 raised to power negative 10 ampere. So to write it in accordance to how the options are written there, so we have 20 microampere, 0.2 nanoampere. So let's write this in form of nanoampere. So that will be, if we multiply this by 10 raised to power negative 1, that will be 0.2. Then what is left here will be 10 raised to power negative 9 ampere, and which is 0.2 nanoampere, and that's the correct answer to that. Okay, to question 68 now. To question 68, it says that radius of curvature of a lens is 12 centimeters. Then it forms an upright image which is 3 times the size of a real object. It forms an upright image which is 3 times the size of a real object. So what that means basically is that the magnification equals 3. Magnification equals 3, meaning that it is 3 times. However, this is the thing. Whenever upright image is formed, always know that the image is virtual. And when image is virtual, magnification will be of negative sign. Take note of that. Magnification is of negative sign whenever the image is virtual. And then every erect image produced by a lens or even a mirror, they would always be virtual. And don't forget that magnification itself is the ratio of V to U. So that implies that we can easily write V in terms of U, such that V will be equals to negative 3U. So, and we have the radius of curvature in this place. That means that the focal length will be 12 centimeters divided by 2, which is 6 centimeters, because focal length is the half of radius of curvature. So from there, what we're looking for is the distance between the object and what we're looking for, yes, is the distance between the object and the image. So meaning that we would need to find the object distance and the image distance. Once we find these two guys, then we can find the distance between the two of them. So let's go using our mirror formula. Using our mirror formula, we know that 1 over f equals 1 over u plus 1 over v. Now, so in this place, I can substitute the values that I have already. This will be 1 over 6 equals 1 over u plus 1 over negative 3u, because v I've been able to substitute that as negative 3u. So this is 1 over 6 equals, so when you find the LCM in this place, you have 3u, then this will be 3 minus 1. So that implies that 1 over 6 equals 2 over 3u. So when you do this properly, that implies that u equals 4 centimeters. 4 centimeters. So because it's a real object, so it should give a positive value. And so then this definitely implies that v, which we have been able to get as negative 3u, will be negative 3 times 4, which is equal to negative 12 centimeters. Now, what does this imply? This negative sign is just showing that this is formed on the same side as the lens, because whenever virtual images are formed, the virtual image is always formed on the same side as the lens, on the same side as the object for lenses. But for mirrors, virtual images are always formed at the opposite side, which means behind the mirror. So in this case now, that implies that this 12 centimeters is on the same side. So let's say if we have the lens, if this is the lens, and then we have the principal axis here. So the object initially was at a distance of 4 centimeters. And that implies that the image was formed somewhere here as well, because it's a virtual image. And this virtual distance is 12 centimeters. So we are now looking for the distance between the object and the image. So if this is 12 centimeters and this is what? 4 centimeters. So automatically whatever is left here will be the distance between the object and the image. So in that situation, the distance between them will be, what is left here will be 8 centimeters. So the correct answer is 8 centimeters. 8 centimeters. That's the distance between the image and the object. Okay, moving on to question 69. Question 69. So it says that a boy is X meter tall. So that will be the object. So height of the object is X. Then also we're given that it stands 180 centimeter from a pinhole camera. That means that the object distance is 180 centimeters. So object distance is 180 centimeters. Then another information that we were given in that question is that the dimension of the pinhole camera is 30 by 30 by 30 centimeters. So what that implies is that, you see, in a pinhole camera, the image distance will be 30 centimeters like that, because the dimension of the pinhole camera gives the image distance. In fact, with that, it also gives the image height as well to be 30 centimeters like that, because inside the box you have the box like this. So if this is the pinhole camera, which should be somewhat like a square, so in this pinhole camera what we have is that this distance will be the image distance, and this distance will be the height of the image. And since this is a square box, then that means that the image distance and the object distance will be the same. So the formula for a pinhole camera is that height of image over height of object is the same thing as image distance over object distance, which implies that what we have now will be 30 over x, which is what we are looking for, equals 30 over 180. So with this now, we can easily solve this. So that implies that x itself has to be 180. X has to be 180 centimeters. 180 centimeters. So that's the correct answer. So to convert this to meter, this is a very, very, very tricky question. So you might think that, oh, maybe the units, they made a mistake or something. So converting this 180 centimeters to meter, you get 1.8 meters. 1.8 meters. So kindly take note of that. Okay. Now to question 70. So question 70 says that we have an astronomical telescope in normal adjustment. So if an astronomical telescope is in normal adjustment, basically what this thing means is that the sum of the focal length of the objective lens and the focal length of the eyepiece, they would be the sum of them. The focal length will be the distance between the object and the eyepiece. So that's basically what that means. So in that question, we have been given the distance between the objective and the eyepiece lens. We have been given the distance between the objective and the eyepiece lens. So according to what I've said now, the sum, so f of the objective plus f of the eyepiece must be equal to that sum that we are given, which is 57 centimeters. So distance between the two lenses will be 57 centimeters, given that the astronomical telescope is in normal adjustment. So we have been given some information in that place. We were given the focal length of the objective lens. We're given the focal length of the objective lens. So with that, we'll have that the focal length of E will then be 57 centimeters minus f of objective lens, and since that is the case, this will now be equal to 57 minus f naught was given as 50 centimeters, so this will be 7 centimeters. So we have the every information that we need now. We have FE and we have FO. So the question asks us that what is the focal length of the eyepiece lens and the magnification of the telescope respectively. So with this now we have been able to get the focal length of the eyepiece, which is what, 7 centimeters. So our next line of action is to find the magnification. So magnification is always FE over FO, and since we know our FE already, our FE equals 7 and our FO equals 50. So hence the magnification is that. So the FE is 7 centimeter and the magnification is 7 over 50. Now moving on to question 71. In question 71, we have that a lens has a power of +5 diopters. So +5 diopters. That implies that the focal length will be 1 over +5. So in that case, 1 over 5, that would give us 0.2 meters. 0.2 meters. So to convert this thing to centimeters now, this would be 20 centimeters. So we just multiply that by 100. So that is 20 centimeters. So now we have been given the object distance as 5 centimeters. So to get the distance between the image and the object, we need to first of all get the image distance. So let's use our mirror formula for that. 1 over f equals, by the way, our focal length will also be positive because our power is positive. So 1 over u plus 1 over v. This implies that 1 over 20 equals 1 over 5 plus 1 over v. That implies that if we solve this very well, v will then be equal to 20 multiplied by 5 divided by 20 plus 5. Sorry, 20 minus 5 rather. That will be 5. Okay, so let me do that one after that. So that will be 1 over 20 minus 1 over 5 equals 1 over v. So in this place, we have the LCM to be 100. So this will then be 5 minus 20 equals 1 over v. So which then implies that v will now be equal to 100 divided by minus 15. So 100 divided by minus 15, that's approximately minus, so that's negative 6.7 centimeters. So having this negative sign means that our image is virtual, and from what I've already explained earlier, if this is the lens, that implies that if the object is somewhere here, which is like 5 centimeters, then the image is somewhere here. No, the image is further. So the image is somewhere here, which is a total distance of 6.7 centimeters from the lens. So if this is 6.7 and this is 5 centimeters, so the distance between the two of them will just be 6.7 centimeters minus 5 centimeters, which will be 1.7 centimeter. So the correct answer there is 1.7 centimeters. Okay, let's move to question 72. For question 72, we have iridium source has a decay constant of that. The half-life of the source is okay, we are looking for the half-life. So this is it. Half-life is ln2 over decay constant, or 0.693 over the decay constant, because decay constant is ln2 is 0.693. So we have 0.693 divided by, so in that place we have been given the decay constant. The decay constant is 1.36 times 10 raised to the power minus 11 per second. So let's do that on our calculator. 0.693 divided by 1.36. Okay, so that's 0.509. So that is approximately 5.1 times 10 raised to power 10 seconds. So that is the half-life of that. So but since the answer is being we have this big answer, we have to convert it to days, hours, or any of the thing that will suit the answer that we are given. So from seconds to hours, we know that inside 1 hour, we have 3,600 seconds. So the first thing I could do here is to divide this 5.1. I will divide it by 3,600 times 10 raised to power 10 divided by 3,600. So with that, it's still giving me a big number. So that means that we can try converting it from hours to days. So that means that all of this time is actually 141,666. Then we have 66.67 in hours. So now let's convert this to days now. So to days, we know that inside a day we have 24 hours. 24 hours is inside 1 day. So let's see how many days this is going to be. Let's see how many days this is going to be. So this is going to be divided by 24. So we divide that answer by 24. It's still a big number. So let's see if we can do years. So we have done days now. So to get the number of years inside the result, we now divide this further. So I'm dividing this thing by 24. When you divide it by 24, you get a certain number of days. Now, but we can convert that days to years by dividing it by 365. So when you divide this thing by 365, so you get approximately 1,617.2 years. And that will be our answer. So to three significant figures, this will be approximately 1,620 years. So that will be the correct answer to that question. So to question 73, the values of x and y respectively for the gravitational constant. So the dimension of the gravitational constant, we know that F equals gm1 m2 over r squared. So we know that G will now be equals to Fr squared over m1 m2. The dimension of force originally is mlt raised to power -2. R will then take L raised to power 2. Then m1 m2, both of them are in kilogram, so that will be m raised to power 2. So that implies that if we reduce this further, m will be raised to power -1, 1 minus 2, L will be raised to power of 3, and T will be raised to power of -2. So respectively, the values will be -1, 3, and -2. -1, 3, and -2. So 74, we have that a body which weighs 30 kg in air displaces 5 kg of water when partially immersed in water. Calculate the upthrust on the body. So this is a very, very simple question. We have been given the weight of water displaced. So upthrust is also the weight of water displaced. Yes, upthrust is also the weight of water displaced. So basically, we just need to convert that 5 kg, just multiply by what? Multiply by 10, and that will give you 50 newtons. So that is basically what upthrust is. Upthrust is the weight of the liquid displaced. That is what, according to Archimedes, a body experiences a loss in weight, that is upthrust, which is equal to the weight of the fluid displaced whenever they are partially or totally immersed in that fluid. Okay, let's move to question 75. Question 75, we have that in the diagram above, if the atmospheric pressure is 760 millimeters mercury, what is the pressure in the chamber G? So basically what you need to analyze is that, so let me just sketch the diagram. So it looks like this. So from here to here, we have 10 centimeters, and from here to here, we have 3 centimeters. You see, the open end is always the atmospheric end, and this place we have 760 millimeters of mercury. Now, total pressure is always the atmospheric pressure plus or minus the gauge pressure. So now we need to calculate the level where this chamber G is, since if this place and this place is 10 and this place is 3, that means that whatever is left from here to here is 7 centimeters. So from that 7 centimeters, we need to convert it to millimeters, knowing fully well that 7 centimeters equals 7 times 10 raised to power negative 2 meters. So to convert this to millimeters now, so we just multiply the result by 10. So that will be 70 millimeters. So since it's going down, so we are going down, total pressure will now be the atmospheric pressure plus the gauge pressure, because we are going down. If we are going up to the chamber G, we would have to subtract. So this will be 760 plus 70, and this will be 830 millimeters mercury. Okay. Question 76. A force of 15 newtons stretches a spring to a total length of 30 centimeters. So we have force of 15 newtons stretches a spring to a total length of 30 centimeters. So basically what we know here is that L1, we don't know it, but we know force 1, which is 15 centimeters. And then we don't know what extension is as well. So in this place, we know that extension is always L2 minus L1. So that implies that at least we know that from Hooke's law, F equals K times extension. That implies that 15, this is not 15 centimeters, this is 15 newtons. So we know that 15 equals the spring constant multiplied by the extension, which will be L2 minus L1, which will be 30 minus L1, like that. So going forward in the question, we're given other information. We're told that another additional force of 10 newtons stretches the spring 5 centimeters further. So we can see this in different way. We can consider the fact that 10 newtons will stretch this thing by an extension of 5 centimeters. That one is the easier way to actually go about it. So when the force is 10 newtons, then the extension is 5 centimeters. So extension, it's not as if it stretches it to a new length, that 5 centimeters is a new length. That 5 centimeters is already the extension, which in meters is 0.05 meters. So I think we can retain this thing in centimeters, so that we just be consistent. So this is centimeters. So with this information, we can quickly get our K. Our K, since F equals KE, that implies that 10 equals K times 5, which implies that K will be 2 newtons per centimeters. K will be 2 newtons per centimeters. So the question we are looking for is that what is the natural length? Natural length is L1. So we can just substitute K into this equation, into this first equation. You know that 15 equals to 2, then 30 minus L1. So that implies that we have 15 equals 2 times 30 is 60 minus 2L1. So that implies that 2L1 equals 60 minus 15. 60 minus 15 is 45. So hence L1 equals 45 over 2. And 45 over 2, that will be 22.5. Yeah, so the result of that is 22.5 centimeters. So 22.5 centimeters. Okay, let's move on. We have question 70. That was question 77. So question 78 now. No, question 77 now. So which of the following is in neutral equilibrium? Which of the following is in neutral equilibrium? So to identify the one that is in neutral equilibrium, let's see. A heavy weight suspended on a string, the beam of a balance in use, a heavy base table lamp, a cone resting on its slant edge. So the correct answer to that is a cone resting on its slant edge. That is neutral equilibrium. So this is what that looks like. So this is neutral equilibrium. 78. The purpose of the constriction in the stem of a clinical thermometer, the purpose is to prevent the backflow of the fluid. That is, so it says magnify the graduation marks, no. Prevent the mercury from expanding beyond the bulb, no. Prevent the mercury from falling back into scale. Yeah, that's the correct answer. Prevent the mercury from falling back into scale. 79. One special advantage of alcohol over mercury as a thermometric liquid is that it has very low freezing point. Yes, it has a very, very low freezing point. So it's able to measure low temperatures than mercury. That's the only advantage it has. In terms of every other thing, no other advantage. Okay, one of the special, okay, 80 now, 80, in Fleming's right rule, the thumb, the forefinger, and the middle finger, if held mutually at right angles, respectively represent. So the thumb is always showing the motion. And since this is right hand rule now should talk about, so the thumb is motion, and then the forefinger, which is the next one after the thumb, is always showing the direction of the field, and the middle finger will show the direction of the current. So the correct answer in this place is motion, field, and induced current. So A is the correct option in that place. 81. For question 81, we have a piece of radioactive material contains 2000 atoms. If its half-life is 40 seconds, the time taken for 124 atoms to be remaining is, so from what we know that the new number of atoms equals n naught multiplied by 1 over 2 raised to power t, where n naught is the original amount and n is what is left. So in this case now, for 125 atoms to be left, and original atoms that we start with is 2000 atoms. So 1 over 2 raised to power t. So we have to solve for t in this place. So we do 125 over 2000 equals 1 over 2 times t. So what we need to do is that we need to find a way to make this thing a power of 1 over 2 as well. So to do that, originally 125 divided by 2000, when it is reduced into the simplest fraction, is 1 over 16. So this is 1 over 16. 1 over 16 is the same thing as 1 over 2 raised to power 4. So 1 over 2 raised to power t. So the implication of that is that t will be equals to, means 4 half-lives. Sorry about that. So 4 half-lives. It must have undergone 4 half-lives to get to that. So this would then imply that the total time it took will now be 4 times 40 seconds, which will be 160 seconds. 160 seconds. Okay, so let's move to question 82. The question is talking about the electromagnetic spectrum, which is R MEVOX G. R MEVOX G. So what happens is that as you're going down, the wavelength is decreasing, but as you're going down as well, frequency is increasing. So wavelength decreases downward, but frequency increases upward. So if this is decreasing, that means that R will have the highest wavelength. So R is the one with the highest wavelength. And for frequency, G will be the one with the highest frequency. So G will have the highest frequency. So the correct answer is, so you know who has the highest frequency and you know the one who has the highest wavelength, like that. Okay, let's move to question 83. Question 83 now says that vibration of air column produces the sound in, that is a flute. A flute. So let's move to question 84 like that. For question 84, it says that soldiers crossing suspension bridges are usually ordered not to march in steps so as to avoid damage at the bridges as a result of resonance. Yeah, it's resonance. When you cause another body to be vibrating in their natural frequency due to the vibration from another source. So 85 now. Heat transfer by convection in a liquid is due to, now for the convection liquid, the heat transferred is due to the fact that there is movement, there is a translational motion between the molecules of liquid, and that is what actually is responsible for the heat transfer by convection. So we have 86. When it is applied to one end of a metal rod, the molecules at the other end soon begin to vibrate with great amplitude than before because heat has been transferred by conduction. So when we have solids, they transfer heat by conduction, because the average position of the particles still remains the same. They are only just vibrating. For 87, a man standing some distances away from a burning wood is warmed mainly by. So if a wood is burning and you're standing some distances away from the burning wood, then you are warmed by convection. Now this is the thing. Burning wood is different from charcoal fire. Anything that is burning, so convection current will set up. So you are warmed mainly by convection. So if it was, let's say, charcoal fire now, then you'll be warmed mainly by radiation. But once that thing is burning, so the heat will be transferred to you through convection. So let's move to the next question. 88. The vacuum in a thermal flask helps to reduce heat loss by, it is by both convection and conduction. By conduction and convection. Some of these things, I've taken a video on them on TikTok, so you can check them out to check the full details of how these things happen. Okay, the next question is 89. In a thermal flask, the silver surface and the insulating cork prevent heat losses by, so the silver surface is by radiation, while the cork support is by conduction because they are poor conductor. So that is correct answer. Radiation, conduction, that's the correct answer. So 90, which of the following statements are correct? Land and sea breezes are natural convection current, that's correct. Convection may occur in liquid or gases, but not in solids, that's correct as well. 3. The vacuum in thermal flask prevent heat loss due to convection only. No, that's not true. It is due to convection and conduction. So only 1 and 2 are correct in that statement.